Okay, we're going to talk about this, moving on to section 1.4. This is solving systems of equation. We'll start off doing it with two variables. There's three ways to do it. You can do it by substitution. And substitution, what you do, it says write one of the equations, so it says variables equals. So what you're going to do is pick one of the equations and solve it for x or y. So solve one equation for x or y. You want to pick one that looks the easiest to solve for x or y. Then take whatever that is and substitute in to the other equation. So if you solve one equation for x, take that x equals whatever and plug it into the other equation in place of y. Then that will get you to solve for one variable. Once you find that one, you go back to one of the original two equations and plug that in. That'll give you the other variable. When you get done, you'll get an ordered pair, x, y. If it ever works out that you get like 0 equals some other number so that it's not true, that means it has no solution. So the two lines do not intersect. If you substitute in and you get like 5 equals 5 or 0 equals 0, that means the two are the same line. Right, so that's substitution. The second way to do it is by elimination. In elimination, what you want to do is you're going to get one of the variables to cancel out. So you look at your coefficients and say, okay, which variable will cancel out? You do whatever you can to make that happen. Combine the two equations. One of the variables cancels, so you're left with one. Solve for that variable. Plug that into one of the originals, and that'll give you the second variable. Again, we'll do some examples of that. The last one is by graphing. Graphing by hand it can give you an idea, but it's really difficult. It's best if you can graph it with a calculator. We'll do it that way, just to make sure you remember how to do that. That's by far the best way to do it, by graphing. Here at the bottom is just some of the types of solutions. Notice I said no solution is if you get an answer like 3 equals 4. Well, you know that's not true. So these two don't intersect, so they're parallel lines. Most of the time, you'll get one solution. So they intersect in one point, so you get the point 2, 4. Then infinitely many solutions is if you get the same thing, something that's always true, that means they're the same line. Okay? So let's do some examples. The first one on here, first couple are substitution. So you want to look at your two equations and say, what can we solve for? Well, I looked at this, and it looks like the easiest thing to solve for here is x. So let's solve for x. So let's move the 6y to the other side. So x equals 8 minus 6y. Now we're going to take that and plug it into the other equation. So in that first equation, wherever there's an x, so right here, we're going to put that in its place. So we're going to have 3 times all of that, 8 minus 6y, plus 4y equals 10. Now, we need to distribute this. So 24 minus 18y plus 4y equals 10. Let's combine like terms. If we put these two together, that's a negative 14y. And if we move that 24 to the other side, that'll give us a negative 14. Now divide both sides by negative 14, we get y equals 1. So we found one variable. Now to find our x variable, let's go back to this one we solved here, and let's put 1 in for y. So x equals 8 minus 6 times 1. Well, that's 8 minus 6, x equals 2. If we want to check our answer, let's go to the other equation. Let's plug those in here. If we did that, we'd get 2 plus 6 times 1. Let's plug it into the first equation, since we used the second one. We plug it in the first one. We have 3 times 2 plus 4 times 1 equals 10. Well, that'd be 6 plus 4 equals 10, so it checks out. So our answer is the ordered pair 2, 1, x, y. Okay. Or this one. Again, we want to look what's the easiest. Well, it looks to me like it's easiest to solve this top one for y. So let's hit y by itself. So let's move the 5x to the other side. So it looks like that. Now we're going to take that and plug it right here in place of this y. So we have 15x minus 3 times, and for y we're going to put 1 plus 5x. Make sure you put it in parentheses, because here that'll make a big difference, because of that negative. Okay. Now distribute, so we have 15x, here negative 3 times 1, and negative 3 times 5x. So we have that. Combine like terms. 15x minus 15x, those cancel out, so we're left with negative 3 equals 9. Well, that's obviously not true, so this one has no solution. So that means if they asked you, these two are parallel lines. All right, that's substitution. So again, pick one of the equations, solve it for a variable, plug that into the other equation, then that'll give you one answer. Plug that into the thing you first set up, that'll give you your second one. All right, now the other method is elimination, the second one. In elimination, you want to get a variable to cancel out. Well, this first one's pretty simple, because notice we have a positive 3x and a negative 3x. So if we just add these two together, our x's are going to cancel out. So those cancel out. 4y plus 6y is 10y. 6 plus 24 is 30. Divide by 10, we get y equals 3. Now we take that answer and plug it into either one of these top ones. It makes no difference. Let's say we plugged it into the first one. We have 3x plus 4 times 3 equals 6. So that's 3x plus 12 equals 6. 3x equals negative 6. So x equals negative 2. We want to check that. We plug that into the second one. We'd have negative 3 times negative 2 plus 6 times 3 equals 24. So that'd be 6 plus 18 equals 24, so it checks out. That's our solution. So our ordered pair is negative 2, 3. Make sure you always list in orders, x first and y. Now this next one, notice here nothing matches up, but if I took that top equation times 4, then things would match up. So if I took it times 4, that would be 4x plus 4y equals negative 28. So now if we add those two together, well, the x's cancel, the y's cancel, so we get 0. 28 plus a negative 28 is 0. This is that case where this is always true. So that means these are the same line. So this has infinitely many solutions, and they're the same line. Sometimes then they'll ask you, like, if you had the ordered pair, you'd say, well, if I solve one of these, let's say I solve this first one for x, I get x equals negative y minus 7. So the ordered pair might be x, comma, negative y minus 7 is the way you'd write an ordered pair. That's something this Big Ideas Math does that I haven't seen in another class. Sometimes, and this isn't on your sheet, but I'll add one, sometimes you'll have, like, let's say I had 3x plus 4y equals something, and I had 2x plus 5y equals something. So here you might have to multiply both. So let's say I wanted to get rid of the x. You might multiply the top equation by 2 and the bottom equation by a negative 3. Some students think of this as cross multiply, because the 2 from down here goes here, and the 3 goes here. The reason this is a negative 3 is that way they'll cancel when I add. But sometimes you'll have to multiply both by something to get it to work. Okay, that's elimination. Now the third way is by graphing. Now here they've kind of done something ahead of time. You need to, in order to use your calculator, you'll need to solve for y. I'll just do this by hand at first. Here by hand, this is our slope-intercept form. So that means our y-intercept is -1. Our slope is 2. That's rise over run. So we go up 2, right 1. So this line looks like this. This line, the y-intercept is 2. The slope is 1/2. Again, rise over run means up 1, right 2. So this one goes here. Now this one's pretty easy since we've got this same point right here. So the point of intersection, if our graph is right, should be 2, 3. If we do that on our calculator, you go to y equals, see, if you ever turn it on, you see how that plot 1 is highlighted? You want to unhighlight that. Because otherwise you'll get an answer that you don't like a lot of times. So we're going to put this in here. So 2x minus 1 and 0.5 x plus 2. Remember, the xt is always the xt theta up here. Let's see what I'm pressing. Yeah, the x button is xt theta. So you put them in there. And I'm going to hit, a lot of times when I first start, I hit zoom 6. Because if you changed your window ever, this will get you back to the normal window. I hit zoom 6 a lot. So zoom 6, now it's going to graph that for me. There's our first graph. There's the second graph. Now we want to know where they intersect. Now to find out where they intersect, you're going to hit second, calc, and see how number 5 says intersect. So I'll write that down. So you're going to hit second, calc, intersect. And it's going to ask you 3 questions. It's going to say first curve. Well, it lets you jump from one to the other. Well, we only have 2. So when it says first curve, hit enter. When it says second curve, hit enter. What that lets you do is if you have like 3 lines graphed and you want to find where 2 of them intersect, you can pick which 2. We only have 2. So we're going to hit enter, enter. Now it'll say guess. You really don't have to. The only purpose for guess there is if you have 2 curves that intersect in more than one point, you can get close to one. If you move your cursor, if you can see that very good. See, I'm moving it closer to that point. You don't have to. It should be all right. You can just hit enter again. But you can move your cursor until you're close to the point you're looking for. And now hit enter one more time. So now at the bottom it says they intersect at the point 2, 3. Well, that's what we found over here. This one worked out pretty good by hand because it came to an obvious point. A lot of times, depending on how you make your line, it doesn't. That's where the calculator is really handy. So again, on your calculator, you enter them in. You have to solve for y, enter them in. Then hit second calc intersect. When it says first curve, hit enter. When it says second curve, hit enter. And then for guess, you can move your cursor closer to the intersection point, or you can just hit enter again, and it should show up. And that's the first part of section 1.4.